Getting started with a NoSQL database in the cloud can be intimidating, but it doesn't have to be. CosmosDB is a powerful NoSQL database system that can be globally scaled with very little effort. Best of all, CosmosDB scales with you, meaning it can be expensive or even free to start while giving the ability to grow over time. In this video, we're going to look at how to set up a free instance of CosmosDB. Then we'll connect a C# application to our new database, learning how to perform inserts, updates, deletes, and read operations, basically all the CRUD operations. This will allow you to quickly get started in a specific database type in your application. Now, before we dive in, I want to share a few things with you. First, if you're interested in improving your C# skills, be sure to subscribe to this channel. With over 650 C# videos and counting, it's the perfect place to learn and grow your skills. Second, if you're looking for free C# resources, head over to iamtimcorey.com and check out the resources tab. You'll find my podcast, the C# projects page, and much more. Third, if you're ready for a deeper dive into a specific C# topic, including Azure or CosmosDB or databases in general, I have a variety of courses that can help out. Not only will you receive a world-class education, but you'll also help fund my free content so that everyone can have a great education in C#, not just those who can afford it. So let's jump over to Azure. This is my Azure portal, and it's looking a little bare right now. I have a dashboard that has nothing in it. So let's get started. Now, this does have a prerequisite of you knowing how to get started in Azure, how to set up your Azure account. Azure has a free account you can set up that it may require a credit card, but you don't have to pay for anything. There's a number of services that are free for life that you can use, as well as there's even more that you can use for the first year for free and more. For example, you can have up to 10 websites hosted for free. Plus, there's Azure Static Web Apps, which can be even more websites you can host for free. Plus, there's free SQL and free CosmosDB and more. So Azure is a great place to learn and get started, as well as to put your actual business. This is where all of my business stuff runs practically. So all the things that I need for my actual business to run, I put into Azure because I know it's reliable and I know it's scalable as I need to scale. So what we're going to do today is create a new resource, and we're going to search for CosmosDB. Now, if you're not familiar, CosmosDB is a NoSQL database. What's NoSQL database? Well, it's another word for it is typically a document database. Now, there can be other types of NoSQL databases besides document databases, but we're going to use the document database. And what's a document? Well, it's just a JSON object. So you can store basically these structures that are a lot more complex than a relational database like SQL would allow you to do. And we'll see how to do that. So create an Azure CosmosDB database. And you come up to this screen, and it can be a little intimidating at first, but don't let it intimidate you. What this is an indication of just how flexible CosmosDB is. What we're going to choose is the Azure CosmosDB for NoSQL. This is the most common choice and one that, if you're just getting started, is probably the right one to choose. However, if you're looking for a Postgres database in the cloud, Azure CosmosDB for Postgres is a great option. If you already have existing code, an existing database that's in MongoDB, but you want to switch it over to CosmosDB, well, the Azure CosmosDB for MongoDB will allow you to more easily transition from your current database into CosmosDB. Or if you want to look at Cassandra or Gremlin, those are other options for how to structure your CosmosDB. Or if you're coming from the Azure Blob Storage and using tables for your data, well, the Azure CosmosDB for table allows you to transition there as well. So a lot of different flexibility in how you can set up your CosmosDB and how it can even run. But for us, we're going to choose the NoSQL, this upper left-hand option. This is, again, the most common one. So we need to choose a resource group. I create a new one. I'm going to call this Demo CosmosDB. You can name it whatever you want, but what this will allow you to do is when we're done, we can delete the resource group And then any resources inside of it can also be deleted then. So that way we don't have to keep track of what other things were created. Now, with Cosmos DB, you're only creating one object, so it's not as big of a deal, but I really like to create a resource group per activity that I'm doing. That way, at the end, if I want to get rid of everything, I delete the resource group and everything inside gets deleted as well. It's another safety check to make sure you don't have unexpected charges on your Azure bill. Now, again, we're going to use the free Cosmos DB, so that's not really a big deal, but it's still something to think through. Okay, so for database name, we need to give it some type of unique name. So I'm going to say this is the I am Tim Corey demo. And that's going to check and see. And yes, that is available. Don't call yours I am Tim Corey. Call it your name or something similar. So this is my database name now, or my server for Cosmos DB. Now, there's many different options here for what to choose, and they do impact pricing. So I want you to make sure that you choose things that are going to be what you want for your setup. Okay, so with that in mind, think through, do you need availability zones? For me, right now, I don't. So I'm not going to create availability zones. If I did, it will improve availability and resilience of your application, but it could have pricing impacts. So knowing up front, yeah, I don't need that is important to know. Now you may think, well, my application might become Google scale at some point. And for that, first of all, don't plan that far ahead. But second of all, you can't change this particular thing. It's actually not that hard to move from one Cosmos DB to a different one that's configured differently. So there is the ability for you to do that in the future. You can't do it once the account is created for this particular account, but you can create a new one. So there is an upgrade path. It's just not straightforward like just saying, oh, change that. No, you have to create a new account and move things over. So we're going to choose Central US for the location. And there's two ways to check or two ways to work through capacity. So what we're going to do is we have provision throughput. That means we have access to the throughput we need. So we say, you know what, I need this much throughput. And don't worry about what the number is. You know, it uses RUs, but don't worry about that for now. Just think in general terms, okay? So you're saying, I'm going to reserve a pool of resources for my use. That's what provisioned throughput means. I'm reserving this many resources that I will always have access to. Or you can go with serverless. What this means is that it's cheaper, but it's typically for smaller workloads. Meaning, if you have a less used database, then maybe serverless is the right option because of the fact that it's cheaper, but it kind of fills in the cracks. Meaning, it takes the kind of leftover resources and uses those, and you pay based upon your usage in a little bit different manner. And what is that pricing difference? Well, first of all, we're going to use the free tier discount, which is going to give us a free tier. That's what we're going to use today, is a free version of Cosmos DB. But let's talk about if we didn't have that free tier, if we're comparing provision throughput to serverless. Let me bring in the Azure pricing calculator. And this pricing calculator, if you go to azure.com/en-us/pricing/calculator, or just Google Azure pricing calculator, you can add the Cosmos DB. And when you do, down here, you can play around with what are my costs going to be based upon my usage. So for Cosmos DB, you have the standard provision throughput or the serverless. And we're going to talk about each. So let's talk first about the provision. That's this option on the left over here, which is where we kind of reserve some capacity. So if we reserve a capacity of 400 RUs per second, so that is 400 request units per second of usage. And what is a request unit? Well, it's a little complicated. It's based upon the complexity of the query and the amount of data it has to query. So we're going to see this when we actually do our testing. So we'll get there. You'll see how our user are at least displayed, may not have it calculate necessarily. We can kind of start seeing how the queries generate a different number of RUs per query. But again, this is per second. Okay, so what we're talking about here is, if a query, let's just say a query costs 5 RUs. Well, that's no big deal. It's within the 400 RUs per second. But imagine if we had, let's say, 20 people making that same query. Well, now it's 100 RUs per second because we have 20 people in that same second making that request. You can see how this actually is pretty generous, pretty easy to do or easy to use because of the fact that typically you don't have a very high workload all at once. Typically, it's over the course of a day, you have people come in and out. But if you have a spike in traffic, well, that could be something to think through. But in this case, with a standard provision throughput, single region write, okay, so we're talking about not doing multiple availability regions. Then we have a 400 RUs times a full month. That's 730 hours. That would cost us, we can say that it's central US, doesn't really matter for this. For this, it is $23.36 for our database. That's what it would cost for accessing the data in our database. $23.36. Now you'll also pay, notice if we have a 1 gigabyte database, that's 25 cents more. And we can also talk about the different types of backups. So continuous 7-day backup is free until June 30th, 2024. After that's going to cost something. But in 30 days, what's going to cost us 25 cents because it's 1 gigabyte of backup. Okay, so that's going to cost us total for the month $23.86 if we had provisioned 400 RUs for the full month. Now, if we up that to 1,000, then we're looking at something like $58.90 for the entire month. Compare that with serverless. Serverless is not based upon per second, it's based upon total RUs. So if we choose the right region as central US, and we say times 1 million RUs, not per second, it's just in general 1 million, we pay 28 cents per million RUs. So with 1 gigabyte of storage and 1 million RUs used, we're going to pay 53 cents for the month. This is why a low usage database is going to be much more cost efficient or cost effective to use serverless. Because even if you say, well, I want 10 million or 100 million, it's not to get to about 100 million that you start to break even with your 400 RUs per second amount. Okay, so this is where you have to figure out what works best for you, but you have this calculator to kind of tell you what your options are and what makes sense for your budget. For me, especially if I was getting started, I'd probably use serverless because of the fact that you can really start to scale up without any negative implications until you get to a much larger state. But then if I decide, you know what, I'm going to have a heavier scale, maybe I would go with the provisioned and then work through what that size should be and how it should work. So it's up to you how you want to do this, but for us, what we're going to choose is provisioned with the free tier, which gives us 1,000 RUs and 25 gigabytes of storage. That's an estimated $64 per month of discount that's applied to our account. So we have one CosmosDB for free, and this one gives us $64 per month of value for free. And that is going to be free for life. So you can enable this one account per subscription that you can use for free for life. Okay? And we can also do is limit the total amount of throughput that can be provisioned. That way we don't have unexpected charges. So we're saying, hey, cap that thing out so that way we don't have to worry about, potentially going over that amount in our testing. Okay, so next, global distribution. We're not going to have geo redundancy or multi-region writes. Yes, you can do this if you decide that you want to have an application that scales up significantly. Okay, networking, we're going to leave that alone. Backups, right now, for free is a continuous 7 days. Continuous 30 days is very, very cheap, but we're going to leave it on periodic. So we'll leave that alone as it is. For encryption, we're going to have the service managed key for that. You could have a customer managed key for your encryption. That way you kind of control the encryption even more, but we're not going to worry about that. Tags, we're going to leave alone. Wait for it to be validated, and then we'll hit create. This is going to create for us our free CosmosDB database. It's going to set everything up for us in our resource group called Demo CosmosDB, and we'll be able to then start working with it with our C# application we'll start to create. Okay, so while this is working, what I'm going to do is come over to our Visual Studio. We're going to create a new project. We're going to create a console app, something really simple, and we'll call this CosmosDB demo and CosmosDB demo app. We'll put this in our practice folder. And .NET 8, we won't use top-level statements, and we will not enable ahead of time publish. Okay, once this is created, we'll get rid of our sample code. And I'm going to go right to our project file and just paste in the 4 packages we need. This is just easier than trying to go to the NuGet package manager and adding all 4. But if you want to, since you don't have this necessarily to paste, unless you watched my last video last Monday, if you don't have this, just look for this package and then this package and so on down the list of all 4 packages. Okay, so you save this. What it's going to do is bring down those NuGet packages, restore it to my application, and now I can use these in my application. Okay, so we're going to start with var builder to bring in our iConfiguration equals new configuration builder. And that adds a using directive. We're going to say add base or set base path. And we'll set that to directory get current directory. Again, what this is doing, in case you didn't watch my previous video, what we're doing is we're going to add app settings.json. And actually, for us, we're just going to add secrets.json. That's all we're going to worry about. I'll add the ability to look for app settings.json, but we're not going to need to add that. So we'll say add JSON file and say app settings.json. And optional is true. And then what we'll do is we'll add user secrets. Whoops, for program. There we go. So what this will do is it's going to look for the configuration for our application. It's going to look in for app settings.json, which is optional, which I'm not going to include. Because I don't need that, I just need the secrets. And I could just not include this line, but I wanted to include it because of the fact that I wanted you to have the option to just add that if you wanted to have it directly. But I'm going to create a secrets file because I don't want to give away some of my CosmosDB secrets. So we're going to just use secrets.json. Okay, so now I can say iConfiguration and say config equals builder.build. And this will give us a configuration to pull from. So now you can pull from our configuration and get the values that you want. So let's create, right-click and say manage user secrets. And in here, I'm going to set up CosmosDB and an object inside here. I'm going to say endpoint. And I'll leave it empty for now. We'll also have primary key. And we'll also have, comma, and database. So those are the 3 things I'll put in my secrets.json file so that we can access them without having to check these into source control if we were to add this to source control, or since I'm giving you this code, the code's linked down in the description, I won't be giving you this, which does mean that, you know what, I probably should give you the app settings.json after all. Control-Shift-A, app settings.json, just so you have it, that structure. And I'll also go in here and select the property and say copy if newer. That way, again, you have this as the starting structure. Just copy this structure and put it in your secrets.json so that you can have your secrets protected as well. Okay, so now what I'm going to do is I'm going to add the NuGet package we need for CosmosDB. And it'll actually be 2 of them. So let's right-click on our CosmosDB and say Manage NuGet Packages. And we're going to say want the Microsoft, if I can spell it right, .azure.cosmos. And there we go. The version right now is 3.41.0. Yours might be slightly different. That's okay. And then the other one we need to have is the Azure.identity. This will allow us to basically identify our app and say, yes, we're authorized to access this. We hit apply, accept. Okay. So with this, now what we can do is we can start working with our CosmosDB. I'm going to set it up. We haven't yet gone back to look at our CosmosDB. It should be created by now, but let's finish the initial setup. So Cosmos client control dot to add the using directive. We're going to say client equals new, and then let's put it on separate lines here since it's going to be a little bit longer. We'll have config dot get value. It'll be a string, and we're going to ask for the Cosmos DB endpoint. And then I'm going to ask for the config. You know what? Let's copy and paste this because it's a pain to type out. There we go. And the other one is the primary key. And then we'll close this out like so. So what it's going to do is get us a Cosmos client. And it's going to start by saying, hey, where's the endpoint? That's a URL to connect to CosmosDB. And then what's the way to authenticate you? In this case, we're going to use a key that has been generated for our specific CosmosDB. So let's look and see if we have our CosmosDB set up yet. And if we do, then we can, yep, we do. Let's go to a resource. And okay, it jumps right to the quick start. We're going to ignore the quick start. Okay, so let's just go back to overview. And what I was trying to do is create for us a sample setup project and all the rest. We're not going to do that yet. First, we grab this URI right here, Uniform Resource Indicator or identifier. So we copy us to the clipboard. This is going to be our endpoint. Let's go over to secrets.json, go to endpoint, and this is not super secret necessarily. Anyone can have this because they have to authenticate, but it's something that I'm going to put in my secrets just because that way I'm not kind of stepping on somebody else's toes who might have a different database in a different location. Okay, so next up we need is the primary key in the database. Well, let's set the database up first with the primary key after that. So the database, you go to database or data explorer down here. What we'll see is ignore the welcome screen and ignore the home message. We can see we have data here and nothing. So what we need is a container and a database. So if you look here, we can add a new container or a new database. Let's add a container first. Let's add a database first. Do that backwards. These names, yeah, they get backwards. So the database is the think of a database like a SQL database, and a container, think of it like a table. Okay, so let's give it a database ID. We're going to give this is a name of some type. So we will say that the name of a database is called SampleDB. Okay. And you want to provision throughput that is being shared across all databases. We're going to auto scale, and the max will be 1,000 RUs per second, which is our maximum we can do for our account. But you could change this. You could say, hey, for this database, I want it to be a lot lower. I want to, kind of slow this one down because it's a sample database or it's a test database or something else. So you don't have to have the same, capacity on all of your different databases. We hit OK. And once this is done, it will create a database for us. We can then put a container in. We're just going to put one container for this demo, but this is the start of you saying, hey, this is how I want to set up my NoSQL database. And again, it's up to you how you do this, but I would encourage you to learn about NoSQL because NoSQL is not the same thing as SQL, meaning it's not a relational database. You don't want to have a person table and address table and a phone numbers table and all these different tables for basically what equates to one really real record. Instead, you'd want to have one record. Maybe it's a person table, but inside of that person object, you'd have addresses and phone numbers and other things that are attached to that person. It's a different way of thinking. So now we have our database, we can create a new container. And it says either create a new database ID or use existing. We're going to use existing, SampleDB. And our container name is going to be, let's call this people. And indexing is automatic. We'll leave it on for now. And partition key. So a partition key depends on how you want to set things up. And again, there's a little bit more information here about partition keys, but here's the general way to think about partitions. So inside of a NoSQL database, it will create the logical partitions and then physical partitions. What is a partition? Think of it as your data. So what will happen, I'll create a little bit of a drawing here. It's going to be really bad. That's okay. So a logical partition, let's just say we do it on a zip code. Okay. So if it's, 1, 1, 1, 2, 3, we're going to put it in this logical partition. So record 1, record 2, record 3, record 4. Whereas if your zip code is, 2, 1, 1, 1, 1, it's going to put it in this logical partition. Now, these two logical partitions allow the NoSQL database, in this case CosmosDB, to kind of group records. And that way it makes it easier and faster to query records. It also allows you, let's just say that we're going to kind of split up our database into different physical spots. Well, what we could do is put this logical partition on one database server, database 1, and this one on database 2. That will allow for better performance and scalability. And it's breaking them up logically because of the fact that you might be looking up people based upon regions. And it might not put just one logical. In fact, it probably won't. It'll probably put multiple logical partitions on one physical partition. But that way, what can happen is if you do a query and you're only querying it in here, well, that's much faster than querying on this server and this server. But it allows you to have this separation that makes it so that you can have multiple servers and scale up and even grow globally. So partitions is a whole deep rabbit hole you can go down. But here's what we're going to do. For a smaller database, and by smaller, it can be millions of records. But for a smaller database, it can be good to just use the ID as your partition key. And that's what we're going to do. So a partition key cannot be changed after the fact. Okay. So when we say /ID, that's saying, hey, that partition key is always going to be ID. So slash means the top level of your JSON document. So if you want to have something one level deeper, you could say /ID/test. That is a test object inside of the ID object. I'm sorry, the test property inside the ID object. So if you choose the ID, which is typically a string value that would be like a GUID, well, then that will have separate logical partitions for each different GUID, which is a lot of logical partitions, and that's okay. And that will allow for very high read or high write scenarios very efficiently. Now, if you decide, hey, I want to group things like by zip code, which will allow me to more easily query things in a particular zip code, because I do that a lot, and it gives me a way to kind of group data together that might be queried together, well, that could be a different way of approaching this. However, when you decide, let's just say I chose zip code here. If I choose this, well, then that record zip code cannot be changed. So when you decide, hey, I'm going to use zip code, well, then you cannot change that user zip code, which means they can't move without creating a new record. That's not typically great. And so you might have to do some different things in order to approach this differently. Maybe it's the first zip code or creation zip code or something else. But in our case, we're going to keep it simple and use ID, which will be a GUID, which will never change. So we're going to leave it at that. It will create a logical partition per record, but that's okay. Okay? So you can have hierarchical partition keys and other things, but we're not going to get into that. Now, once I choose that key, I cannot change it. Meaning I can't decide I want to use zip code now instead of ID. Sorry, you can't do that. Now, that's not the end of the story, because there are ways to change it, which I guess there wasn't, right? There are ways, but basically what you're doing is creating a new container and then moving all your data into that new container with the new partition key. So it can be done, and there's a tool to do it right in Azure, but just know it's not as simple as just changing something, because of the fact that this is how the logical and even physical partitions are decided. Now, in our case, we'll only have one physical partition. Not a big deal. Okay? So I just want to kind of introduce that to you, because there's a lot more down this rabbit hole with partition key. But in the cases of getting started and until you know better, just use ID. Okay? So that's what we're going to do there. We're not going to worry about unique keys here. This, again, could add another layer of ability to query things more easily, or we're not going to add the analytical store. Okay, so with that, it looks like, am I missing something? Okay, there we go. So we have our SampleDB database, container of people. We're indexing of automatic. We have partition key of /ID, which means the ID property. Okay, so we're set now to create our container. We hit OK. Wait for it to create, and this will create our container inside of SampleDB. It will not have any data in it yet. That's okay. So we have people, and then items. There are no items. All right, so now we are ready to start working on putting data into our people container and then taking data back out, modifying, and so on. So now let's go back to here and say our database is going to be our SampleDB. Okay, but now we have primary key. So come down here to keys, and we have our URI, and we have read-write keys as well as read-only keys. So I'm going to do read-write keys. I'm going to grab my primary key. Now, I'm going to show this to you, but don't freak out, because what I'm going to do is, after we're done here, well, first of all, the database goes away. But second of all, I can just say this refresh button right here, which regenerates the primary key. It destroys the old one and creates a new one. But if I do this little show primary key here, then I can see my primary key, and there's a copy button over here. I copy that. I will unshow the primary key, and I can come back over here and paste into my secrets.json my primary key. Again, this goes away, not a problem. So now I have my endpoint in my primary key, which will allow me to create a client that can talk to CosmosDB. Again, coming back over here, Data Explorer, we can close this out and go to People. We have nothing in items right now. We will change that in just a minute. Let's start by creating a connection with our database. So database, we'll call it db equals client.getDatabase. And we're going to grab the config value. Let's just copy this right here. Makes it easier. And we'll put a semicolon at the end. And we're going to say this is our database. So again, we have our, let's go back here, our endpoint, our primary key in our database. And so we're going to grab the database here to get our database connection. From there, we're going to create a container. Container, we'll call it container, equals db.getContainer, and our container name is people. Now you could put that into our app settings.json or secrets.json, but this one's a little harder to do that because of the fact that you may be querying from multiple containers. So it wouldn't make sense to have just one container in there. You might have multiple, and maybe you do. Maybe you put multiple there, or you have a constant at the top that fills that in, so you don't have the quote unquote magic string of people. It's up to you. But we're going to grab the container for our people. Now what we're going to do is do an insert. Now we have our container, we can actually insert data. And in order to do that, well, we need to have a model. So let's create a model. So Control-Shift-A, we'll call this person model. And let's get rid of our unused using directives. We can make this a file scope namespace and change this to a public class. Yeah, lots of little tweaks here. I'm going to create a string called ID. Now, right now, because I said lowercase ID, it's going to want a lowercase ID coming in. I'm going to show you what this is going to do if I use the proper casing for C#. It will break. That's okay. I'll show you how to fix it. So what we're going to do is say equals GUID.newGUID. Now, .toString. Okay, now what this does, it creates a new GUID every time we instantiate the person model. That way we don't have to worry about this. If we're instantiating this and not pulling it from the database, it's going to generate a new GUID for me. So that way we always have a new GUID we can insert. And we get to specify, hey, this is the ID of what we're inserting into the database. So next I want to have string first name and string last name. And we can make these nullable strings, that's fine. Because they could be null, but I don't think they're going to be. Okay, so now we have this object we can play around with. Let's insert a new person. In order to do that, let's actually just do insert person here. And we'll say person model person equals new, and then let's create a first name. We'll just start with Tim. Last name equals Corey. Keep it simple. And now it's going to create a new record with first name and last name of Tim Corey. Okay, so now we can say is item response for type person model. Response equals await. This is asynchronous. This is an async await call. So await container dot create item async and pass in person. This is going to create for us our person object inside of CosmosDB. Now the the return value is an item response of person model. Why is that? Well, because the item response gives us a number of things that we can look at. For example, we're going to do this quite a bit, so we're going to copy and paste this eventually. But I'm going to say that curly braces here, and we'll say response dot request charge are used for this call. Okay, what does this mean? Well, the response tells us the number of RUs or request units that each call made. So when we insert a person in the database, we can check how expensive that was. And we can even then use that to do things like validating that one way of querying is better than another way, or identifying which are the expensive queries and so on, because we can check right away what each response or each call, how expensive it was. So with that, let's put our, I'm going to leave the console.readline off. Just note that if you're running it outside of Visual Studio, it will close immediately. You have to put a console.readline at the end. But when you're running it inside of Visual Studio, it will wait for us. So this is all the code we need. So we've got the endpoint and primary key to create a client. We grab a database to create a database. We grab the container we need, and we just say, hey, here's a new object, container at create that item asynchronously. And then we'll print out how expensive that was. That's what insert takes. Let's run this and see if it works. Okay, so with this, wait for it. We have an error. Let's see what the error is. Well, there's no error message here, but if you go to view details and look at your exception, it says response status code does not indicate success. Bad request. The input is invalid because the required property of ID, notice all lowercase, are missing. Okay, so there's a missing ID value. Well, no, it's not missing, right? It's there. Well, no, it's not, because it's uppercase ID. So what do we do to solve this problem? Well, what we can do is decorate this and say we want JSON property. Now it's going to add a using directive up here. We're going to say JSON property, and then the property name equals ID, all lowercase. What this does is it says, hey, I know this is the C# name, but for the JSON, we're saying it JSON, that's the actual name. Kind of translates that to the correct casing. Now, let's try this again. We run this, and it says 6.29 RUs for this call. So that one insert that had 3 values, ID, first name, last name, took 6 RUs to insert. And if we come over here to our portal, we hit the refresh button here in items, we'll notice that we have a new record. So we have ID, there's the GUID. We have the first name of Tim. Sorry, it's a little small. But my zoom's not working. But first name of Tim, last name of Corey. Here, I can zoom in this way. Boom. So ID, first name, and last name. We have some additional things, the RID, the self, the E tag, the attachments, and the timestamp. Ignore those. Those are for CosmosDB. You don't have to worry about those. Your object, when it comes back, will just be the things that you ask for, in this case, these 3 things. So we now have an insert working. So let's go ahead and escape out of here, and we'll go over to our Visual Studio. And it appears as though I've lost my mouse cursor. No problem. I can work around this, I think. So we'll minimize this, and we will close this. And how about that? I actually can work around a little bit without a mouse cursor. Okay, so now we've got our item response. We can actually do a call and insert. So let's now comment this out. And what we're going to do is we're going to come down here, and we're going to do now a read. Okay, I think I have my cursor back now, which is great because that was annoying. So let's start with the item response. Let's say read 1 record. We're going to say that we want the item response. And in here, we're going to say person model. And we're going to say response equals await container.read item async person model. And let's put this on a new line because it's going to get kind of long. And what we need in here is we need two values. First of all, we need the ID, and then we need the partition key, which is new partition key. And then inside here is the actual partition key. So let's go back over to our data and look at my ID first. So there's my ID for Tim. Okay, so I can come back over here, and that's my ID. But what's my partition key? Well, your partition key is whatever the key is for that particular partition, which we chose to be the ID, which is really convenient for us because it's the same value. So just paste it in again. So now we have these two values. And again, I apologize, they're on multiple lines because it's so large. But what we're saying is read the item. Which item? Well, we want this particular ID. This is looking up one record based upon its ID. And then you want to say new partition key with that same value because that's still what we're looking up. Yes, we're duplicating this in theory, but the reality is that the ID and the partition key might be different. And if they are, these would be different values. But in our case, because of simplicity, they're not different values, they're the same value. Okay, so now we can do is we can say we want to, let's first of all grab the cost. So there's the cost for that. And we're going to say another console write line. And this time we're going to say what the first and last name is. So here we'll say that the response dot resource, that's what comes back, dot first name. Because notice that response dot resource is a person model. The resource is the value that's returned. Okay, we'll put space, and then I'll just copy and paste this again, and we'll grab the last name as well. Last name. All right, and that should be it for reading our value. So let's run this again. We're not doing the insert, we're just doing the read. This is one request unit for this call, Tim Corey. And it's a very cheap call. Notice that it's much cheaper than the insert because in this case, it knew specifically where to go to get this specific record. It didn't have to do a lot of looking or querying. Okay, so that's how to read one record. Now let's come back and let's comment this out. And we're going to come back over here and we're going to insert another record. So we'll undo this and let's add Sue. Okay, so we're going to insert the record and we'll see that it inserts and it's 6.29 RUs for the call. Okay, so now you've done that, you may say, well, Tim, why did you do that? Well, I wanted to have more than one record in my database. So if we refresh now, notice there's two records, one for Sue Storm, one for Tim Corey. With that being the case, we can now do a query. So let's query for all the records. So feed iterator, person model. We'll call this feed iterator as a name equals container dot get query item get item query iterator. There we go. Person model. There's many different options here. Let's put this on a new line. So we have a little more space here. And then inside here, I'll put this on a new line because we're going to need even more space. We're going to say that the query, well, let's leave it off for now. Let's just leave it blank and say there's no query. It's just give me everything. Okay. And then we're going to do a while loop. While feed iterator dot has more results. And here's the kind of the cool efficient thing this is doing is that this is going to loop through the calls because it might give us a set of records, but not all the records. So it might say, hey, here's the first 100 out of 1,000. Instead of giving us all 1,000 records, which we might not need, it's going to give us the subset because, again, we're paying per request unit. So the more efficient it can be, the better. So what it's going to do is this while loop is going to say, no, we actually want to loop over every single set of data. So think of this like the pages in a table, where you might have a table full of data, but then it says page 2, page 3, page 4, and you can click to those pages and get more data in that table. That's what this is doing. This is paging through the different pages, but inside of a particular page, then what we're going to do is we're going to grab that particular page of data. So feed response of person model, call response equals await feed iterator dot read next async. So this is saying, hey, grab the next page of data, and let's grab our command here to give us the cost for that particular page of data, and we're going to do a for each. And we're going to say for each var p in response. Okay, so that's going to be for each person model. Let's just spell it out for you. For each person model p in response. So the response is going to be a list of person model. And we're going to say console write line. And then let's grab again the this right here. We'll change it a little bit because it's not response.resource, it's just p. So for each person's returned, write their first and last name. Okay, loop through that. But again, since we only have 2 records, only 1 page of data, therefore we have to loop multiple times. But this will allow you to loop multiple times if there were multiple pages of data being returned. So it's a nice little feature that allows us to kind of grow as we need to with our query. All right, so let's run this. And we do, it's 1 RU for this call, and we get back Tim, Corey, and Sue Storm. So it's not a very expensive call because of the fact we're getting all the data, and there's not a lot of data being returned. And so it's saying, hey, there you go, 1 RU, you got Tim, Corey, and Sue Storm. So that's a pretty cheap way of getting our data back, and it gives us all of our records. So that's how you read everything. But what if you wanted to query and say, well, actually, I want to have a more specific record? That's where, again, in this get query iterator, instead of putting blank, we could put a query. We could say the query text, put a colon, and the query text is basically like SQL calls. Select star from people, that's the container, where people dot first name equals, and put in single quotes, Sue. So I'm only going to request records where the first name of the person is Sue. We run this, and we get Sue Storm, but notice 2.82 RUs. So because it's not indexed, and because of the fact that it's having to figure out which records to return, it's actually more expensive in this particular case to ask for just that one record, as opposed to asking for all of our records, which seems counterintuitive. But with such a small data set, that's how it works out, which means that if you have a small data set, it might be simpler and cheaper to get all the data back and then query with LINQ. Whereas when you have a larger data set, it might be better to, first of all, put an index on the data you're looking for, you're querying on. And then second of all, thinking through how you could better optimize your calls. So this is why being able to see what that RU value is very helpful. Okay, so now we've seen how to insert records. We've seen how to read one record. We've seen how to read multiple records. Now let's comment this out. And this is, by the way, read all records or query for specific records. Okay, so just, again, I'm commenting this so you have each section. Again, you can download the source code in the link in the description. Okay, let's talk about updates. So item response for person model response equals await container. Oh, I misspelled that badly. Read item async for person model. Okay, so we're going to grab the read, which actually have this up here. Let's just grab the. There we go. Let's just grab it like this, and I can put a new line and uncomment these. Okay, so this is a read. And you're saying, wait, Tim, you're reading a record, not inserting a record or updating a record. Yes, I know, because I'm trying to grab a specific record. In this case, I'm grabbing the Tim record. And now I'm going to do is say var user equals response.resource. That just kind of shortens down, takes this and puts it into here. Again, if you remember about your object, it's not making a copy of the object. It's just adding a pointer to that place. It makes it easier for us to then work with it. What we're going to do is we're going to say that user.firstname equals Timothy. Let's get more formal here. Okay, so I'm going to change from Tim to Timothy in my name. I'm going to say that response equals await. I use that same item response object. I say await container dot replace item async, and we're going to say user and user.id is the ID, and then the new partition key is going to be user.id, because we know that that's the partition key is the same as the ID. It makes it super simple. So that's going to update our user. And again, let's grab our console write line for our use. I'm going to grab this. I'm going to paste it after our lookup. We should do it there. And we should also do it at the end here, because again, we're doing two calls here. Therefore, we need to make sure that we kind of keep track of both of those when we're thinking about how expensive these calls are. Okay, this is going to do an update. All we're going to say is, hey, there's the new RUs for this. We'll look at the actual data to see it. Okay, so 1 RU and then 10.67 RUs. So that's a more expensive update, right? But if we come over here to our data and we refresh, Tim is now Timothy. So yes, we do have the correct update here. It was a more expensive call than just the lookup. And that's what I think through is different types of calls have different values for expense. But even at the cheapest account, like we're right now for our free account, we have 1,000 RUs per second, which means that very expensive query of updating, well, we could do 100 of those per second and still be roughly inside of our window, really more like 9 or 90 some because of our 10 point something. But that means we can still do a lot even in our free tier. But it's something to think about when we talk about optimizing our data, is thinking through how to optimize these calls to be the least expensive possible. Okay, so this is our update data, and we will comment all of this out. And again, you can't just run this because of the fact that your ID will be different than mine. So make sure you update your IDs in order to match. Okay, so now let's talk about deleting a record. Well, to do that, we're going to say the beginning here, item response, person model response, that's the same, equals, let's do this on a new line, await container dot delete item async. We'll delete a person model, and we're going to do this on a new line. The first we're going to do is we're going to grab a key. Let's grab Sue, just because we've been working with Tim so far, and let's grab Sue. Let's copy the ID. And come back over here. We will paste it in here. We're going to put a comma, and we're going to say new partition key and the same value here. And then we'll put our closing bracket or closing parenthesis and our semicolon, and this deletes our record. And again, we're going to grab how much this costs to do. So paste that down below and run this. And when we do, it took 6.29 RUs to delete this record. And if we go back over to our CosmosDB, we refresh the table, we only have one record, and it's for Timothy. Because Sue Storm is now gone, we deleted that record. So we now have, let's comment this, delete user. And again, make sure that you change your IDs because they'll be different for every record. But that's our delete user. So we now have seen how to create a CosmosDB database and container and set it all up in Azure for free, how to connect to it right here, and then how to insert a person, how to read one record, how to read multiple records or query for records, and then how to update data and how to delete data, as well as evaluating how to make sure we understand what a call is going to cost based upon our specific data and our specific table. So that's how to use CosmosDB. That's the very introduction to it, but that gets you started and gets you able to work with this and start to try these things out. If when you are done, first of all, let's go back over to our Azure. If you say, hey, I accidentally showed the entire world my primary key, that's that value that starts with 3P, I can hit refresh here, and it's going to regenerate my primary key. And when it does, my primary key will no longer start with 3P. So this is taking a bit, but when it's done, I'll have a new primary key. And I'll still show you because of the fact that I'm going to delete the whole database. I'm going to show you that next. Okay, it just regenerated my primary key, and notice it now starts with 4U. So that's different, which means that if you'd seen the original one, well, it doesn't work anymore, in which case even my application won't run anymore. But again, you just saw that one. Not a problem. I'm going to delete this whole thing. Now, I could come over here to my overview and say delete account, which what that will do is it will delete the database and the containers and all my data and all my backups. That's going to do everything. But just note that there's no going back from that. It's a one-way trip. Once you delete it, it's gone. The other thing you can do in Azure, though, just it's even more destructive. So just be very, very careful. But when you're doing demos, this is what I love to do, is notice we have the resource group of demo-cosmosdb. If you click there, that will take you to the resource group, and it will list all the things in the resource group, which, because we created CosmosDB, there's only one thing in the resource group. However, if it created a storage account for us or a web app or something else, it would show all the things in here that are attached to this resource group. But another benefit, and here's the super destructive thing, but it's also something great for testing, is you can say delete resource group. When you do, everything inside of the resource group will be deleted. It goes away. So if I hit delete resource group, I hit copy here, it's going to say, hey, all the dependent resources, including hidden types, are shown. These things will be deleted. Okay, so I paste in the name of my resource group to confirm deletion, and I hit delete. And it says, hey, are you sure? It's permanent. It can't be undone. So if you get through all these different warning messages and still are surprised, that's kind of on you at that point. But yes, I'm going to delete this. Now it's in the process of deleting everything, which means that even though I use a free account, let's just say I hadn't used a free account. Let's say I had decided to use a paid account, maybe the serverless account. Well, I will not be getting any more future charges from this because everything will be deleted. I won't have one lingering thing hanging out there that runs up charges that I don't know about. So I cover all this protection, how to do it, and more in my Azure course. on iamtimcorey.com. I go into much more depth into how to protect yourself, but I always like to make sure that when you're playing around with the cloud, it's very important to learn the cloud because the cloud is very, very useful for business, especially small business, because it's actually very cost efficient if you do it right, if you do it for the right reasons, the right ways. But it's also very dangerous because if you don't know what you're doing, you can run up very expensive bills. But Azure is pretty good about giving you some good safeguards, and I teach you how to use those safeguards. But the biggest ones are use a resource group and then delete the resource group when you're done. That way you don't have any hidden charges that show up. Okay, this will take a little bit, but then my CosmosDB is going to go away entirely. All right, so that's how to get started with CosmosDB, especially working with C# with it, and how to do the full CRUD operations against it. I hope you found it valuable. Thanks for watching, and as always, I am Tim Corey.